Module 5 is rational functions and equations. In this video I'm going to talk about objective 1, 2, and 3 of topic 1, which topic 1 is to simplify rational expressions. In this video again, it's going to be 3 objectives in one video. So the first objective is factor rational expressions. Objective 2 is to state the excluded values from factored form of these rational expressions. And then finally, objective 3 is to cancel out like factors after you state exclude values and then write the simplified rational expression. Alright? So, to begin, I need to scroll back up. I'm going to do one example, number 1, and then I'm going to ask you to do number 2 on your own within this video. So, we're going to take it objective through objective. So there's 3 objectives in one video. I put a hint here that helps remind me of what strategy to use for factoring depending on how many terms exist. If you remember way back from Module 3, if there's 3 terms, I use the MAC-AB strategy, or find factors that multiply to the outside and add to the inside term. And then if there's 2 terms that exist, I'm going to find the GCF, factor that out, so divide each term by the GCF, and then write what remains technically in factored form. So those are just clues to help you remember which type of strategies to use for what type of expression exists. Now, the biggest thing about rational expressions, if you remember, all that means is there's a numerator and a denominator. So if you look at number 1, there's a numerator, 2x cubed minus 2x squared, and a denominator, x squared minus 5x plus 4. And so it's a fancy word for a fraction that has a top and a bottom. If I was going to perform objective 1 on this example, factoring the rational expression, I would first look to see how many terms exist. And I know that the top needs to be factored because typically when it gets to factored form, there won't be any higher powers of x cubed and x squared in this topic. And so because there's higher powers of x cubed and x squared, I'm going to try to factor out the x squareds and then also the 2 in this case. And if you notice, the top has 2 terms, so if I'm going to factor out the top, I'll rewrite it down here. Rewrote the top as 2x cubed minus 2x squared, right? And I'm going to show how I'm going to factor this piece. And then I'm going to show how to factor the bottom piece in just a little bit. And this should be a review, so I'm going to go a little bit quicker on the strategies themselves. But again, the first thing, 2 terms. So I know because of 2 terms, I have to find the GCF and then divide each term by the GCF to write it in factored form. So the GCF of the numerator, 2x cubed minus 2x squared, the number this time is pretty straightforward. The GCF of 2 and 2 is just 2. So I'm going to write GCF so far that I found is 2. Now, with the variables x cubed and x squared, the lowest power is always going to be, the lowest power that exists amongst all the terms is always going to be the greatest common factor. In this case, the lowest power is 2, so I know that x squared exists as the greatest common factor between the 2 terms, meaning that this term has an x squared and this term also has an x squared, has an x cubed, but I can't take 3 out because this one doesn't have 3 x's present in that spot. So I have found the GCF. Now, if you remember, I'm going to get it to factored form, and this is the main goal of this objective. Please write factored form. To get it to factored form, I'm going to write the GCF first, always, 2x squared. And then I'm going to put parentheses. Inside the parentheses is going to be the division process, all right? So I'm going to take the first term, which is 2x cubed, and I'm going to divide it by, and I'll put that up here, just some side math, 2x cubed divided by my GCF, which is 2x squared. Now, and the answer is going to go in the first place of the binomial, or inside the parentheses. 2 divided by 2 up here is 1. X cubed divided by x squared is just x. Remember, base divided by base, you subtract the powers. 3 minus 2 is 1. So my final answer for this first piece is just x. I don't have to put the 1 in that case. Now, the second term is 2x squared. So if I do 2x squared divided by 2x squared now, everything should cancel out. 2 divided by 2 is 1, x squared divided by x squared is 1. So 1 times 1 is 1. So the final answer there is 1. Now, if you notice, I didn't include the negative. This needs to be a negative 2x squared, which makes this a negative 1. So technically it's x minus 1 because it was 2x cubed minus 2x squared. So this is factored form of the numerator. I am done with that. Now for the bottom, the denominator. If you notice, it is a trinomial. I can identify the a, b, and c. A equals 1, b equals negative 5, c equals 4. I'm going to go a little quick on this because this is technically review. So if I set up a MACAB chart, MACAB T-chart, and I put under MAC 1 times 4, that stands for multiply the A and C, in this case is 4. And the AB, it adds to the B term, which in this case, the B term is negative 5. Alright, there's my T-chart. I've set that up. I need numbers that multiply to 4 and add up to negative 5. Now again, you can go down the line, 1 and its partner 4. 1 and 4 are factors of 4. 2 and 2 are factors of 4. They need to multiply to 4 and add up to negative 5. Alright? In this case, it is 1 and 4, but because the B term is negative, they both have to be negative. Because if the B term is negative and the C term or the MAC term is positive, they both have to be negative. The factors do, because negative 1 times negative 4 is a positive 4, and negative 1 plus negative 4 is a negative 5. Now, I'm not going to, for time's sake, I'm not going to show you how to do the calculator trick in this video, but if you remember, you can put the MAC term into y equals, so you would put 4 into y equals, and then you would hit, or you put 4 into y equals and divide it by x, and then you would hit second graph to bring up the table of numbers that are, that table would give you these numbers down here, the factors, and then you could kind of scroll through and look to see which ones work. If you don't remember how to do that, please ask me and I can show you that calculator trick as you're working through the practice problems. But I have found my factors, negative 1 and negative 4. So factored form for the bottom is, if you remember, it becomes 2 binomials. The variables were x's, so each binomial gets an x. And then it is a negative 1, so it's x minus 1. And it's a negative 4, so it's x minus 4. And I am done. I've factored the numerator and the denominator, all right? Now, I am still going to write it as a rational expression, though. So the top is going to become this piece right here. So I have, oh no, what did I do? Wait for it. There it goes. All right. Good. Yes. All right, the top is 2x squared times x minus 1. That is the factored form of the numerator. The factored form of the denominator is right here. X minus 1 times x minus 4. All right? So in this case, I am done with objective 1. I have gone from standard form or expanded form to factored form. All right? And this is the goal, to get pieces. If you notice, there was only one piece on the top and bottom up here. Now there's 2 pieces in each, the top and the bottom down here. There's a 2x squared technically is a piece, and an x minus 1 is a piece or a factor. And then on the bottom, x minus 1 is a factor, x minus 4 is a factor. I am done with that. So please pause the video and try to get your problem into factored form, numerator and denominator style. At this point, you should have paused the video and tried number 2 on your own. I have factored the top, 3v squared minus 9v. The GCF was 3v. I divided and put it into factored form. I divided each term by the GCF. So my factored form was the GCF of 3v times v minus 3. That is the top, all right? The bottom was a trinomial, so I used MACAB. The MAC term was negative 12, the AB term was 1. And I found, because the MAC was negative, when you multiply to a negative, one of the numbers had to be negative. And so I saw that 3 and 4 would potentially give me 1, and I made 3 negative because 4 plus a negative 3 is 1. If the 4 was negative, 3 plus a negative 4 would have given me negative 1. So this is the correct situation, negative 3 and 4. I put it into factored form, v minus 3 times v plus 4. And then finally I wrote the entire rational expression in factored form right here. 3v times v minus 3 over v minus 3 times v plus 4. Close up that last parenthesis. So hopefully your work looks very similar to that. Now let's move on to objective 2, stating the excluded values. All right. Excluded values just mean the denominator cannot equal 0. All right. That's a skill from elementary school as well. You can't divide anything by 0. So if you notice, and I'm going to do from up here, I'm going to do this example. If you notice, I have 2 factors in my denominator. 2 places where I could put a number in for an x and get a 0. All right. In this case, then, my 2 factors, if you notice in yours, you also have 2 factors. I have to decide, what do I put into those factors that would give me 0? So what would I put into this x that would give me 0 and this x that would give me 0? And so I'm going to write the first factor, x minus 1, and I can solve it just like we've been solving. X minus 1 equals 0 if I add 1. So I get x equals 1 in this case. That is the solution, but because it's in the denominator, I have to exclude 1 from this rational expression. Because if you notice, if I put 1 back into this x, I get 1 minus 1, and that equals 0, and I can't have 0 in the denominator. So in this case, I have to exclude the solution of 1 from this rational expression. All right? So same thing, x minus 1, I'm going to do the other one then, x minus 4. I set it equal to 0. In this case, I'm going to add 4. So x, the solution is x equals 4, yes. But because it's in the denominator, I have to exclude 4 from my rational expression as well. Because if I put 4 into this factor, 4 minus 4 is 0, and that would give me 0 in the denominator. And I can't have that, okay? So these are my 2 excluded values for my problem, all right? Please pause the video and try to tell me the excluded values, what numbers you have to exclude from the rational expression in your problem from factored form up here. So you should have gotten v cannot equal 3 and v cannot equal 4 from these factors right up here. Because if you put 3 into this factor, 3 minus 3 would give you 0. And if you put negative 4 into this factor, negative 4 plus 4 would also give you 0. So you have to exclude those values from that rational expression. All right, so that's objective 2, state the excluded values. We've done it. All right, let's move on to objective 3 then and finalize this process. Objective 3 says to cancel out like factors and write the simplified rational expression, or technically write what remains after you do that process. So in this case, we are still working from factored form up here. So I'm going to rewrite factored form down there just to show you this process. 2x squared times x minus 1 over x minus 1 times x minus 4. This part is the fun part because you can notice things that are the same and you can cross them out. And it is very satisfying to do that. So, the only thing that is, and this has to be the same on the top and the bottom. The only thing that is the same on the top and the bottom in this case is the factor of x minus 1. It goes bye-bye because it exists on the top and bottom. Technically, it's being divided by itself, and anything divided by itself is 1, so it's 1, but you don't have to write 1. You can just cross it out and cancel them out. Now, to write what remains, I have a 2x squared left on top over an x minus 4 on the bottom. And I am done with this process. Now, in order to satisfy your homework and your practice problems, you have to also include the excluded values in your problem. So my simplified version with the excluded values is my final answer. Go ahead and pause the video and try objective 3 for your problem. 3v over v plus 4 and v can't equal